organization for the invitation. I have to start my talk saying I'm not talking about COVID-19. Sorry. I know, guys, we have this problem, this pandemic problem for a while. And in Portugal, we have this also, it's a small country as Neil said, as Belgium, but we have 1,050 cases of death, and now we have just 7 deaths per day. I mean, you are dealing, well with the situation, but my big concern nowadays is with Brazil, where I'm from. Yes, I will talk about different things. I'll talk about forest fire. And in Portugal, it's work in progress, actually. And I have this collaborator, Paulo Soares, and we are together in the University of Lisbon. I have this spatio-temporal analysis, joint spatio-temporal analysis under a Bayesian perspective. And I start with introduction, motivation, modeling, results, and remarks. As a teacher, I'm more used to presenting one thing, in increased order, the logical order. Let's start with the forest fire. The forest fire is a big deal in the summer here in Portugal. It is also a big deal in other countries, as you know, especially in Africa or Australia, Brazil, and European countries as well. Okay. The origin of this forest fire can change. For instance, in Africa, that is associated with the vegetation, the savanna, and I mean, we have more fires, but no big burned area. And here in Brazil, it's different for plantations. People wanted to use the land for another source. And in Portugal, we have this kind of thing. You have very hot summer, and especially in the south, and like Spain, in Italy, and in Greece. And you need to deal with this. And I guess we didn't get to know the key point for this pandemic problem. And as you know, I just got some plots from the website, the internet, and this is one I like it because they can show all the picture. And but I also got this one about the burned area. And in our planet, as you can see, Asia have 47%. It's just an illustration, just And but in Asian, the problem is more associated with the practice of the forest clearance. That means they wanted to prepare the land in order to clean, it for the new planting, right? And in European countries, we have this problem with the forest fire, and but some of them, as you can see here, Portugal, Spain, Italy, Greece, France, and that can be a very big deal for us, especially the countries for the South European countries. They have this problem every summer. I put here these countries, the South European countries here. This is an old series, but you can get a little bit more about this burned area in European countries. And as you can see in black, you have Portugal, in 2 decades ago, no big deal. And but it's increasing in black. And in 2003, I guess, we have a big fire here. And after 2025, we have another outliers, especially in 2017. You have, a very problematic summer here. Some countries are doing well, in terms of control controlling the situation. You can see Spain in pink. You can see Spain start to know worse, but at the end, it's not so bad, especially here in this period. And also Greece. Greece is a surprise to me because but that's true. Fire is an important issue in Mediterranean regions, especially in Portugal, as I say, and they have a very substantial influence on the ecological and economic aspect in our forest. In Portugal, in 2017, we have this big, very strange summer, and you have 100 deaths in the 500,000 burned hectares in burned area. Oh my God, that was very, very difficult for us. And after that moment, actually, the government started to have new ideas, especially involving the society, the university, and the National Forest Authority, and try to put together and get the same thing that happened in the COVID nowadays. I mean, the pandemic, the COVID-19 pandemic. We start in 2017. We started to use this kind of the connection, the link between university and forest authority here. What more? I got this study from the national, this data from the National Forest Authority when they asked me to do some project prediction, this kind of thing, but the data were not so nice. I can show you later, but let's just talk about the forest fire here. Some introduction here. I put Pereira and the colleagues in 2005 point out some variability for the very wet winter and the dry summer. This combination is very, very tough for the forest fire. And actually, I didn't work in 2015 using this kind of the interaction between precipitation and the high temperature in the summer, and of course we found something very normal. I mean, when do you put together these two things, and that can be very bombastic. We also in this paper in 2015 we found a few important covariaties related to the burned area here, and I know some people have the same. Just put here. Okay, I know some people have the same covariaties and the problem in several countries, but one thing it was very easy to see in this paper in 2015 was the proximity of the roads. I mean, if you have a fire, and if the fire is next to the roads, and that means someone can locate the fire, and try to find to combat the fire. That's very important. Also, we realized the type of the mountain elevation can be very difficult in order to attack the fire. I do like this paper of Antonia Tuchman in 2011. I got some of inspiration for my analysis today from this paper. They have this data set from the Australian and New Zealand forest fire, and they have, not like me, I have land fire information, and they have satellite fire information. And because they have a kind of peaks, and they needed to include in the model a probability of ignition. That's very important. It's a kind of the zero inflated, okay, or not if you deal with this situation. Let's see more. Is here. In fact, my motivation for this work is to use kind of my background doing disease mapping in forest fire. Okay, that's the idea. And I have some work with disease mapping, spatio-temporal modeling of the several diseases, and in general, when you have this kind of situation, you try to identify temporal trends, spatial heterogeneity, or try to produce smooth maps. And I try to do the same thing here with the forest fire data. Okay. As yesterday, as Andrew said yesterday, and you can use this data in different ways. I have used, because my data was provided by the National Forest Authority, was aggregate data. In this case, I have aggregate data by district or municipalities. And you have a big series, I mean, 30 years, and I'm not comfortable with all the series, but a part of them, maybe can be useful, that I use it here. What more? Let's see more here. I put this plot here, just so you guys, I don't know if you are familiar with the Portuguese map, I mean the mainland, because we have two islands, and here I have information just for the continental Portugal. And I put here because if you're not familiar with the data, one thing it's very obvious for us is you have more fire in the north, okay? And in the south, you don't have, okay? At least enough. And the continental Portugal is divided here in 18 districts. And as you can see here, if you're looking for the most occurrence of a fire is in this area. And again, this area is the highest part of Portugal. That means a big mountain is here, and it's difficult to combat, to attack the fire. But another thing is very important when we started to work with this data is to know, although there are this kind of difference between the north and the south of Portugal, and in the north is so green, and that means you have fewer, okay? And that can be very useful to understand this difference between the north and the south of Portugal. My first thought about this data was to realize we have no report up to 1991. Many no reports. I mean, here I put just the 18 districts, and as you can see here, you have no report for the first one, Aveiro, Beja, and another one. And after 1991, changed a little bit. I mean, changed a lot for a few districts, and I tried to understand why, and colleagues for the Agricultural Institute, they told me that is related to the change in the law. After 1919, you have new rules to inform, to record, the fires in Portugal. And that means if you wanted to apply for some funds related to to combat the fire, after 1991, you have to have very good data. You have to inform very good for the national to the National Forestry Authority, and based on that finding, we decided to include a kind of the zero inflated. Why not zero inflated? Okay, because we have a lot of zeros. But in fact, I don't know if it's zero or not zero. In fact, it's a kind of missed data because it's just no record there, right? And for today, I decided not to use all the data. I decided to start from 1992, right? And do my analysis and keep this first problem of the data apart from the analysis, from the analysis. Let's compare, or I have done some work with another people and included people from the group, the researchers from Canada, and the group of the Stephen Taylor, Charmaine Dean, John Brown, and they have this big group about forest fire in Canada. And the ones I have tried with this Canadian forest data, and also they told me in the first moment, Giovanni, and in Canada we have a specific origin of the fire, and as you can see, they say, for instance, in British Columbia, they have around 60% of the fires is due to the lighting. And that's not happening in Portugal in general. In general, we don't have this kind of storm like in Canada in the summer, and or dry storm, of course. We don't have that. But in this data, I also realize the Canadian data. I also realize apart from the burning area, the size of the fire, and you can also do some joint analysis with the duration of the fire. And based on this situation, I try to use again my background in this case in survival analysis and try to do some work with the comparison with the survival analysis and this kind of duration analysis. Okay, and in this case, I didn't work with this data, but Dex and G and colleagues in 2020, they have done some work and do again joint analysis with the duration and the size, the fire size, right? And you can see this was published in the Environmetrics, I guess, and this year, all right? Oh, I've just put here this based on that my experience with the British Columbian fire data set. I put this because this is my Vancouver. It's a nice city, and also it's so funny to see, you know, fire in the middle of the ocean, but that happened. When do you work with burned area, fire burned area? Usually you have this kind of thought. What I do, because in fact, if you look at the data in the first moment, you can see you have a lot of fire, but low burned area. I mean, you have this kind, the people, the researchers classify this kind of fire in several categories, and one is less than 2 hectares, and they call no challenging, and the challenging, and the sectorial, and the complex one, right? And that is because that was a concern about this data when we start to work with burning area, it is because what you do with a lot of small values for the burning area, okay? And in Canada, we found that. And I guess if you can just categorize small, like say here, no challenge ones, and try to exclude from the data these individuals, or try to put a probability, a mass of probability in this percentage of the no challenge forest fire, right? And in general, larger fires tend to burn it longer, as you know. Yeah, when you can have a lot of fire, but sometimes just one big fire. I mean, long duration. I mean, large size that can be very, very difficult for all the summer. Okay. Let's carry on a little bit. For the forest fire, you can face this problem in different way. I mean, you can define different outcomes in order to work with. And you can have, for instance, occurrence of the fire ignition, if you need it, to put a mass of probability. You can have the occurrence of fire and inform about the size, fire size, and you have this kind of the point process, or in another case, the geostatistic type of the spatial data. And in my case, I have used the number of the fires, and at the time t in a region I will call aerial data, and in the proportion of the burn area in the same situation. I mean, I'm working the aggregate data, I'm using aerial data, and I will decide to divide my regions, okay, according to the neighborhoods. Okay, that's the idea. The fire duration and the size, and of course, can be studied by space and time. That's my proposal for today. And you have, as I said before, different challengers, the occurrence of the most small size and short duration. It's a lot of them. You can have also the occurrence of the zeros in that situation, as I told you in the beginning, when you have a pixel, and sometimes you have the node have all pixel, it's a all a burned area, or just nothing inside of the pixel. And from my perspective, I think I didn't see yet, but I would like to see and like to work with a situation of the fire attacking different stage of the fire. That means if you have data, some people have, I don't have individual data, individual fire, but if you have individual fire, you can also to do some joint analysis using the moment of you find the fire, and you attack the fire by land, or you attack the fire by air, or you control the fire, and the fire ends. I mean, you can do this kind of the different duration, different times, and try to see how can I understand the fire mechanism from the beginning to the end using these different outcomes. I didn't for a while. I just using all these aggregate data and producing spatial temporal analysis. Let's just summarize what I wanted to do. I wanted to model the number of the fires, and this is my first outcome in region I and time t. And also I wanted to model a second outcome. I mean, the proportion of the burned area, okay, and in the same region at the same time. Of course, I can do generalized, additive, or linear models for each outcomes individually, or I can do something I have proposed for today is do the joint analysis. By the way, for the second outcome, when you have this proportion, I have seen some people using transformation of the variable. That means log, maybe another transformation, arcsine, something like that, in order to get, the Gaussian distribution. And yeah, that can be possible. Actually, I tried that in the past, but for today, I didn't do that. And I want also to introduce a correlation among regions by introduce this spatial round effect. Let's see the model. The proposal today is to present a general spatial temporal model for the two outcomes in terms of the means. And here I'm using two link functions. Of course, for the counts, for the number of the fires, I can use log, and I can use, for the proportion, I can use the logit. And I can spread my structural model, can be something like intercept for each outcome, plus an overall temporal effect, let's see that, and also a kind of interaction between the space and time, okay? And an individual effect for the region, mean effect of region, effect of the overall time, and the interaction between space and time. That's the idea for this. This model was proposed for McNabb and Dean in 2001. I did some base approach specific for the binomial modeling, data modeling 2008. In fact, this parameter here, the spatial round effect, I usually call the spatial frailty. That's because my survival background, and I can use this Bezag conditional regressive model for this spatial frailty. I can also, based on the proper model, I can produce maps. I will call fire mapping in order to describe region and the proportion, and I can here formulate policy decision related to the allocation of the forest fire. Why not? Okay, and that's the proposal of this for this modeling. I just put some illustration for the models. I put 5 models. As you can see here, this is very simple one. It's just a linear trend. And here I put a spline for the overall temporal effect. And a p-spline is an option, another option for overall temporal effect. And a Gaussian process. Why not? It's better. Okay, let's check. And for the interaction, I did something very normal in health studies. I include this kind of interaction, let's say a regional trend. That means for each region, I have a linear effect. That's very important sometimes, because you can just find in the regions the top 10 and the top bottom 10 or top 10. I don't know what you wanted to check, and in order to allocate funds. Why not? Here, you have to connect these two outcomes using this kind of the joint analysis. What that means, you connect the two outcomes by round effects. I put here just an illustration. For instance, for the number of the fire, I have one spatial round effect. For the proportion of burning area, I have 2 spatial round effect. One of them is shared with the previous one, and another is just related to the proportion effect, right? Of course, if V1 is 0, there is no sharing. I mean, there is no loading factor between the two round effects. Let's go to results. No, I have more. Just a few comments about the joint analysis. The joint analysis can be very useful. Like, for instance, you can model the frequency and the intensity of the events in order to explain the mechanism generating the recurrent events of interest. Why not? Or you have something like the number of the earthquakes, and you have the severity of these earthquakes. Why not? You can do together. Good link. And in fact, the first time I saw the joint analysis was in a paper from David Dunson in 2003, when they put together different type of the response. I mean, diff counts, categorical response, continuous outcomes, and put together. And this kind of illustration for this very can be useful for the psychological context. Also, Cindy thing in Chamendin have also a paper in 2011 proposing, a joint analysis, but specific, putting a zero in heavy term, right? But joint analysis, actually, when the people talk about joint analysis, they think you are talking about this kind of the longitudinal and survival outcomes. For instance, when you have this kind of the time to the event data, and you have also a measurement, repeated measurements like CD4, another thing, okay? And that's more usual when you talk about joint analysis. Guys, just to say, we have our splines, we can have Gaussian process, okay? And we have the likelihood, of course, and I'm using the Poisson for the counts, for the number fire, and I'm using the beta distribution for the proportion. Of course, I'm hypermetizing the mean, the parameter of the beta regression, the beta regression distribution, and I put my linear predictor here in the mean of the proportion, and in the variance, as you can see, there is this kind of the precision parameter. That's the idea. I can extend that, include the covariate. It's very easy. I didn't do that, but you can do it. Related to the prior assumptions, I had to say to you, the first time I do this kind of disease mapping, I use intrinsic conditional to a regressive model. That's it. But after I read carefully this paper in 2011 from Lee, with a nice useful comparison study of the alternative approach, I try another's. Lihu in 2002 have this car model, let's say Lihu car model, and even Cressy in 1993, they have this car model. And also, I like this parameter, this whole parameter, because it represents the overall effect of the spatial dependence. I mean, apart from the variance components, you have this whole parameter. I do like it. Of course, there are relations between these car models, but I wanted to emphasize this thing. Oh, another priors. Come on, guys. I use highly dispersed prior, but of course proper prior, and that means Gaussian distribution for the regression parameters, or for the variance components. Actually, I didn't use inverse gamma. It's a little bit controversial nowadays to talk about the inverse gamma for the variance components, but I use the Cauchy distribution. I will tell you why. And I got my posterior. I did put the expression of the joint posterior distribution here, but I talk about the likelihood, they talk about the prior, and it's just easy to construct that. And of course, when you put together all type of the outcomes, and in this case, you have to be careful. I mean, the joint posterior distribution can be not easy to work with. And my suggestion is to use MC methods. In particular, I use the Hamiltonian Monte Carlo implemented in STEM. I know that just one option. You don't need to do the same. Okay, and there are another options. There are the old open bugs. You have actually the new inland. Robert, who is here, I know if I told Robert who I have done my work in Stan, he said no, ILA is better. And of course I did know the model selection, and I used these two measures in order to my selection of the model. And this MCMC approach is very useful, especially if you wanted to estimate quantities of interest. For instance, the spatial odds, when you have the exponential of this spatial round effect, right? You can just implement it easily, and because it's a spec value, it's just easy to do it. We have here some results. To talk about the results, I guess I have a few minutes, but let's just show you a few results. And as you know, I have regions, 18 districts and 278 municipalities. I did two analyses for this guy, but in fact, they are very similar. And for the shared spatial frailty, I just use one spatial round effect for the outcome 1 and just a load factor. I mean, I did put 2 here, and I got better results using this way. I have this introduction. I have here my table, and my last model was the best model, the select model up so far, and I use these two measures based on this model 5. I mean, with the intercept, with overall temporal effect, with this linear trend, regional linear trend, and the spatial round effect, and a Gaussian process for this guy here. And I did more details about here the priors, but let's put here the a plot related to the overall temporal effect. In fact, the splines one, the green and the red, move something, but the big problem for me in order to model this overall temporal effect is I cannot get this highest guy here. Maybe you guys can help me to give me some suggestion. But although that was the best model so far, I didn't get these points. I produced some maps. The maps here, you can just see for the number of fires, I have this linear trend, regional linear trend, and we detect something not usual. We detect this region here. I mean, the high linear trend, and that's not usual. We need to check that. And but for the proportion of the burn area, that's true. They are located, the high ones are located in the north, and here, yeah. And although in this area you have a lot of fire, that means you don't have a lot of large proportion. One more. I like to see this plot here because you can see the spatial round effect for the municipalities and for the districts. And our concern is here, this area next to the Porto city. You have to be careful with this area. You have more spatial, extra spatial variation there. In order to see if I'm proposing a good model, at least in terms of the variance components, I'm comfortable with this data, these results, and I'm so comfortable with the shared, the load factor here, and also the dispersion parameter for the burn area is also big. Okay, I have to understand better that, but it's true. To finish, I guess I just have these plots, and as you can see, the model tried to get these up and downs, And but in fact, when you have this kind of the outlier, it's difficult the model to get that point. Okay, and I need to think a little bit more about this thing. But in general, the rest of the situation, the model doing well. In short, I'm proposing now here spatial temporal modeling for a specific situation with forest fire and in Portugal, and you look some kind of the regional linear trend. You're looking for some extra variation due to the space effect, and you still have something to do. I didn't bring for today the prediction part actually, and because I separate 2 years, but I didn't have a result yet for these 2 years. And I didn't use the zero inflator in my situation because as I told you, I used the data just for the 1992, and otherwise I'm supposed to include a zero inflated term. And one more, some reference, okay? And you can get some reference here. And just to say thank you, Antonia Turkman, for relevant comments, and the project associated with that, it's this one. This is my contact, and I will finish my talk as the previous speaker put some plot, some figure, and this was in 2017 in Portugal. As you can see, that was with 100 people dying in this village at the Pedrógão Grande, Portugal.